The first maps we know of that have survived were about 5,000 years old, on clay tablets. But it was only a few hundred years ago that there was sufficient data and statistical understanding to go beyond just simple maps and actually create data maps that contained information about differences between different places. So that was in the 1600s where that came together. And in the 17th century and 18th century, with the rise of printing and the rise of some more modern mathematics and some basic statistics, there was an expansion of graphics. Most of it, almost all of it, were either maps or simple time series. So those were the most widespread graphics, and they remain probably the most widespread graphics in newspapers today. Just basic maps, maybe basic data maps, and time series plots. This is where Tufte gets into sort of research design issues. But he says, there's something fundamentally unsatisfying about most time series plots in that, the passage of time alone doesn't necessarily tell us what's happening. So yes, things changed over time, but we don't really know why without additional information. Now, sometimes a time series is useful if there are, important events that took place at a certain point. The French Revolution happened and there was a big change that year. Well, that's plausibly related to the French Revolution. So it could be that a time series can get us closer to causal explanation if we enhance the time series with other pieces of data. So that could be useful. But in general, the real progress in data visualization happened when there was this kind of combination of distinct variables and the relationship between them that was independent of a simple time series. And that's really what happened a bit later in the mainly in the mid to late 1700s. So he has a lot of figures by these sort of pioneers in data visualization and graphics, Lambert, Swiss mathematician, and then William Playfair. Great name. And Playfair actually, there's a ton of stuff by Playfair in the book. So what does Playfair do? He basically made time series plots mainstream. He really started using them widely and made them mainstream for the presentation of economic data in a way. They were kind of used in a scattered way before then. He made them widespread. And apparently, according to Tufte, he invented the bar chart, invented the pie chart, and was the first person to use area to depict quantity. So he would, present various types of, economic data, political data, and basically size observations by quantity, like trade quantity or something like that, trade volumes. So he was really an innovator, and this 1786 book was very important. So within a very short amount of time, a lot of these tools became widespread, and these are sort of still what Excel use. If you go to Excel, graph, plotting types, it's still kind of like Playfair's playlist. It's still kind of the same stuff. So what are some of the things that he did? These are some of the early time series. This is trade data. You can see the imports into England and then the exports out of England, and so you can basically see the trade balance here, over time. One thing that Playfair always did is he really integrated graphics into his sort of words into his graphics all the time. And a lot of the early figures do this. And then for a long time, figures in scientific research stopped doing it, but they're sort of, words are back. I think that's the kind of feeling of a lot of recent work. But so this is, the trade balance over time. This is one of the first bar charts, where the dark line, he says at the bottom, denotes, the black lines are exports, and the ribbed lines are imports. So again, he's sort of distinguishing between exports and imports here into different countries. So he's presenting, data in various ways. So what Minard is doing here is he has a graphic on the fate of Napoleon's army when he tried to invade Russia. So for people who aren't, familiar or forgot this episode or blocked it out, Napoleon had conquered most of Europe, decided to keep going east. He should have stayed in Poland. He never should have gone to Russia. It was a huge mistake for him. He decided he was going to go conquer Russia. He left with this massive army, and between the Russians sort of burning every town before he could get there and destroying food supplies and a brutally cold winter, his whole army was annihilated. And shortly after that, he was removed from power. So this is a pretty interesting figure. It's a combination of a time series and a data map to begin with. There's very effective use of color. Let me explain the figure. This is a map. So this is Poland, and I was going east into Ukraine or something, and then into Russia. This is Moscow up here. The orange line is the army he started with going to Moscow. And the thickness of the orange line is how many soldiers he had. And you can see every place he goes, he's losing soldiers to disease, to battles, etc. So by the time he gets to Moscow, which the Russians had burned to the ground, so it was like nothing to eat, there was nothing to do, he had already lost, you can see visually, the majority of his army. Then he had to return. That's the black line. And what's in this bottom aspect of the figure, and this is actually very nice, because the bottom aspect panel of the figure links up to the black line in terms of dates. So at this date, this has the temperature. At this date over here, this is the temperature. And what ends up happening is it was a brutally cold winter with minus however many degrees. So basically, as his army retreated, it was getting colder and colder and colder. So he basically gets back to his starting point with like him, his horse, and his cook or something. So this is a time series in different directions. It's a map. You can see the link to temperature, which has causal explanatory power. It's kind of an amazing figure. And when you think about it, this must have taken a long time to conceive of. There were a lot of different pieces of data. It's driven by a real substantive understanding of the historical episode. It's driven by sophisticated use of data, and it's beautiful. The colors are beautiful. The other thing to note is, the different panels are kind of lined up. We'll come back to this later on in a way that makes them both more effective. Like, if these were side to side, it'd be much less powerful to see that as they kept going, the temperature just kept falling here. So it is, I don't know if, Tufte's right that it is the greatest figure, ever, made or something like that. It's like the Muhammad Ali of, figures or something. But it's a pretty nice figure.